class of physics. This class or this presentation is for grade 11, still at book 4. Today we will go to another title, which is electrical quantities. This presentation is delivered to you by me, Mr. Khalid, and this presentation is for week 5. Actually, this presentation it will cover like some titles and subtitles. We will cover current in electrical circuit. We will say how the current are moving through the electrical circuit, and then we will cover good and bad conductors, which material is good for good conductors and which one bad conductors. Then we will move to what is electrical current, measuring electrical current and electrons, and finally current and a charge. Some of them is subtopic, is not main topic. Okay. Now we will start with electrical quantities, current in electric circuits. So please try open your book on page 186 and follow me on your textbook. Try to follow in parallel in your textbook and these slides. So current in electric circuits. As we mentioned it before, if an electric current is to flow or not to be to flow in a circuit, two things are needed. We need two things for that. What first one is what complete circuit for it to flow or to move around, and something to push it where it around the circuit. This is what the second thing. So we need two things to let what electric current to move or to flow through the circuit. First, complete circuit connected in correct way, and second one is something to push it to move around to the circuit or through the circuit. Actually, the push might be provided by what? A cell, battery, or what? Power supply. The push here, we need something to push it here, so we can put cell or battery or power supply to push the current to move through the circuit, as we will see in next slides. In figure 18.3a, this figure shows how a simple circuit can be set up in a table. So there is lots of ways to connect what electrical circuit. We can connect it in the lab. We will show how to connect it in the lab. How to connect it, it's not in the lab, just draw it by on paper or something, which called electrical circuit, or demonstrated electric circuit. So once, as we will say in this circuit, once the switch is closed, there is a continuous metal path for the current to flow along. So once the circuit is connected in correct way, for example, we have a power of supply here, and we have another things like this one, any components in the circuit here, lamp or supply, voltmeter, ammeter, resistance, something like this. So if the circuit is connected in good way, so the current will start moving like this through the circuit. If the circuit is disconnected or the switch is turned off, so the current will stop moving through the circuit. Current flows from where, as we said before, from positive terminal of the battery. It's a start from the positive terminal. It's very important, don't be confused. The battery, the symbol for the battery is like this. Okay, so the current will start moving from where? From the positive part. This is the positive part, and always the long one is positive, the small one is negative. So it will start moving from positive and then return from where? From the minus to the minus part. Start at the beginning from the positive and returning to what? To the minus one. So always we said that the current is start moving like this. We put a row like this. It's I. It's I. It comes from like actually is not starting from the minus one. It's starting from the positive, but always it comes from the minus to where? To the positive. From the minus to the positive. So it flows through the switch, and then start to the other things inside the circuit, and this current is called what? Direct current, DC, direct current, or DC, as we can see in this circuit here. So this is the circuit here. This is the power supply here, or cell, or battery, or something. There are two parts here. One of them is minus and the other is positive. This is one is the switch, which using to turn the circuit on off, and this is what? A lamp. When you turning the circuit on, so the lamp here will be on. This is switch on off, and this is what? The battery. And then the circuit are connected by what? Wires to this part, and then start from this part another wire here and another wire like this. So this is a complete circuit. If the wire here is disconnected or is not connected very well in this part, or here or somewhere here, so the circuit is disconnected and there is no current will move through this circuit. Figure B 18.3b shows what? The same circuit as presented by circuit diagram. So this one, it's exactly the same one. This one, the previous one, this in the lab. We circuit this circuit is in real measurement or in the lab. This one is presented the previous one for calculation, for drawing it, to do some work on it. So this one is called what? Presented by circuit diagram. This is the circuit diagram. Each component here has its own standard symbol. Each one of that circuit, the previous one, has what? Its own standard symbol. For example, this is for what? This cell, battery, or power supply. This is the minus part, this is the positive part. So current will start moving from positive here like this, and then we still move like this. We will go through the whole circuit and then return where? To the minus part, and then the same like this. So the current will move like this. This is what? I always start from positive and return to where? To the negative part. And this is the symbol for what? Switch. Switch here is what? On. So there is no current. Current cannot move here. And when we close the circuit here, so the current can move through the whole circuit. So as we said, this is a circuit diagram. It is needed for calculation, to do some mathematical measurement on the circuit. And this one, the previous one, is for what? The lab one. This one, this is the real one. It can be connected in the lab. Now we will move to good conductors and bad conductors. So please go to page 187. Actually, materials are different some of them they are good conductors, and the other they are bad conductors. So the wires we use to connect up the circuit are made of what? Metal, because the metal are very good what? Conductors of electric current. The metal is usually what? Surrounded by what? Plastic, so that if two wires touch the circuit, what? Or the electric current cannot pass directly from one to another. This one called what? Short circuit. So this is a kind of what? Here the wire itself is it's very good example of what? Of good conductors. The plastic here, it's another example of what? Insulator or what? Bad conductors. On the other hand, the plastic here are good what? Electrical insulator or bad what? Conductors. So we have two types of what? Material here. We have good conductors, which includes most metals, including copper, silver, gold, steel, and other ones. Good insulators like what? Such lots, يعني like glass, plastic, wood, another polymers, and lots of things. They are very good what? Insulator. So in between those there are many materials that do what? Conduct electricity, but not very well. They called what? Semiconductor. It's located in between, is not good conductor and is not good insulator, so it calls what? Semiconductor. Like liquids may conduct, but they are generally poor conductors. Okay, now we'll move to what is electric current. So what's the electric current? Actually, as we said in last few slides, current flows from where? Positive terminal of supply or the battery or anything around the circuit, and back where? To the negative part, as we said before. So start moving from where? From the positive, and then moving through the circuit until comes back to the negative. This is negative and this is the positive part here. So current flows from the positive terminal of the supply around the circuit and back to negative terminal. This is very important. Keep it in mind. This is very important. Later we will need it. So what is actually traveling around the circuit? The answer is what? Electric charge. It's electric charge. So what's the current by this? A current is the flow of what? Electric charge. So the current is the flow of electric charge through where? Through the circuit, as we will see later in next slides. So the current are moving this way. We will say that the current are moving this way because of what? Because of charges. As we said, there's an electrons and protons. Protons are positive, electrons are minus. So electrons they give the ability to the current to move through where? Through the circuit. Okay, so now how we could measure electric current or measuring electric current? To measure electric current, we use what? As we said before, a meter. And to measure a voltage, we use what? Voltmeter. We use two types, a meter for current, voltmeter for voltage. There are two types shown in figure 18.4. There are two types of ammeters. This one type, this one type, and this one is another type. This one is analog meter, and this one is digital meter. So first one is analog meter. It's connected to the circuit, or with this type of meter it's easy to see when the current flowing is increasing or decreasing. Digital one gives what? Direct value. So it's hard to say when the current is increasing or start decreasing. There's no just actually there's they are used, both of them. Some use analog one and another ones use digital one. If you are going just interested in the value, so and very exact value, so you can use what? The digital one. If you need to say how the current are increasing, decreasing, and when start increasing and decreasing, you can use what? Analog one. So both of them has an advantage. So to conclude, we say that what we use an ammeter to measure what? Electric current, and there are two types of ammeter, which are analog meter, and what? Digital meter. The reading of an ammeter is in what? Ampere. A. So the ampere sometimes there are small values or small current may be measured in what? Milliampere. And another ones it's more small. It measured by what? Microampere. So we have amperes, milliampere, and what? Microampere. It depends on the value of the current. 1 milliampere is equal to 1 milliampere, which is equal to 0.001 ampere. It's equal to 10 to the power minus 3 ampere. They are all same. We can say 1 milliampere, 1 milliampere, 1 milliampere, 0.001 ampere, or we can say 10 to the power minus 3 ampere. 1 micro is what? How many? 3, 5, 6 zeros. 0.00001 what? Ampere. So we have how many zeros here? 1, 2, 3 to the power of minus 3. This one is 6 zeros. 1, 2, 3, 4, 5, 6, which is micro ampere. So milli to the power of minus 3, micro to the power of minus 6 ampere. It depends on the value of the current. Now we have two pictures: current and what? Electrons. Current and electrons, and we will say what's the relation between current and electrons. Please open your book on page 188. Okay, so metals are good electrical conductors because they contain what? Electrons that can move about freely. So here the idea is that in bad conductors such as the most polymerized, what happens here? Actually, as we said before, to let the current move through the circuit, we need what? Two things. What? Complete circuit, for example this one, and another thing here, and this one here. We need a complete connected circuit, and we need what? Something to push what? Current to move, which will be like a battery or power supply, cell, anything. We need something to push current to move. Start moving from where? From positive to the minus part. Electrons here in the circuit actually are moving where? The opposite direction. Are moving in opposite direction. Why? Because electrons here are negative charge. So if we have bad conductor, now we have two things, bad or what? Good conductors. It could be bad conductor, or it could be what? Very good conductors. And what happens here, as we said before, there is in any material or in any metals, there are what? There are this the atom of this one. There are protons here, protons and neutrons, and here surrounded by what? Some electrons. Electrons are what? Negative, and proton are positive. Negative and positive. This one is positive, and the electrons are moving around the protons here, and they are negative charge. They have negative charge. So in bad conductors, such as most polymers, all of the electrons in the material are tightly bounded where? With the protons here. So electrons is not easy to move. They are controlled by what? There is a strong relation or connection between protons and electrons. So they are tightly bounded within where? The atoms. So that they cannot move. On the otherwise metal are different. Why? Because electrons here in a metal are tightly bounded within what? Their atoms. Some are free to move about within where? The material. So they are what? Conduction electrons. So there are some electrons here are freely to move, and is or are not connected very well with where? With the protons. Those electrons, they are or responsible to move the current through the circuit, or by those electrons we can it can be for current to move through to the circuit, and they are these are called what? Conduction electrons. So it's clear here. Figures 18.6 here, a voltage such as that provided by battery here or power. So this is the power supply here. Where is the current? Current start moving from where? From positive to the minus. Positive to the minus. So current flow in this direction, and the electrons are moving where? In this direction. Why? Because electrons are what? Are negative charge, and is connected by what? Here is positive. So electrons, they start moving where? This way, in opposite direction with where? With the current. So a voltage such as that provided by a battery or power supply can start these conduction electrons moving in one direction through the metal, and the electric current flows. Since electrons have a negative electric charge, they are attracted to what? To the positive terminal of the battery, as we can see here in this figure. Because they are minus or negative charge, they will move where? To the positive part of the battery, and the current flow is in this direction, and electrons flow in this or the opposite direction. Okay, now electrical current flows from positive, as we said, they start moving from positive to the negative. And this figure here shows what direction is of flow of a charge around what? Around a simple circuit. So current with the red one, and charge here with what? this flow of current and this flow what of electrons. So in this figure shows what the direction of flow of a charge around what simple circuit, and we picture positive charge flowing out of the positive terminal around the circuit and back into the cell at the negative terminal. Now we know that in a metal, it's what? It's the negatively charged electrons that move. So they leave the negative terminal of the cell. They will leave the negative terminal where? To the positive one, and flow around the positive terminal in the opposite direction of what? Of current. Thus what we have two different pictures of what is going on the circuit, or what's going on in the circuit. We have a current move from positive to the minus, and the electrons in the opposite direction start moving from minus to the positive, because electrons are negatively charged, so they are gonna move to where? To the positive part of the circuit. Now we will say what's the relation between current and charge. Current and charge. As we said in the circuit, they are moving where? The opposite direction. Current start moving from positive to the minus of the power supply, and electrons are moving from negative to the positive. And who is going to push current to move through the circuit is what? Is electrons. So what's the relation between current and the value of charge, or the value of current with the charge? An ammeter measures the rate at which electric charge flows past a point in a circuit. In other words, amount of charge that passes per second. We can write the relationship between the current and charge as in this equation. So what's the relation between current and charge? Current A is equal to what? Charge over what? Time. It's a charge per second. It's amount of a charge that passes per what? Per second. It passes in where? In time. So we can write the relation current is equal to charge over time. So I is current is equal to charge quantity over charge Q over what? Time. So this is the relation between I and charge, current and charge. Current is amount of a charge over what? Time. So a current, for example, of 10 ampere passing a point means that 10 coulombs of a charge flows where? Past the point every second. So every second there are 10 coulombs past that point to give what? 10 ampere. You will find it easier to record this relationship in the following form. It's same. So we say that the charge here is equal to what? Charge C is equal to current times what? Time. Time is time. So Q is equal to I times T. So it's the same. If a current of 10 ampere flows around the circuit for example 5 seconds, so there will be 50 coulomb of a charge flows around the circuit. So the value of a charge is what? A charge is current times what? T times T, or I is equal to Q over T. They are same. There is a strong relation between the value of I and the charge per time. Time and charge. There's a triangle of current, charge, time. Now we will take some worked example to make those things clear. In this example, we have a current of 150 milliampere this current I flows around the circuit for 1 minute. 1 minute. How much electrical charge flows around the circuit in what? In this time. In this time. Step 1, write down what you know here. So we have what I is equal to 150 milliampere, which is 0.5 ampere. We need to transfer it to ampere, or 150 times 10 to the power is minus 3. Time is what? 1 minute. Those things are given where? In the question. We have current of 150 milliampere passing through a circuit in 1 minute. 1 minute is equal to what? 60 seconds. So we need to find what? Q. What's the value of, or how much electrical charge flows around the circuit in this time? Q. A Q is equal to what? Step 2, we write down what? The form of relation, or the equation of relation between Qi and T, and then what? Substitute the values in this formula. So Q is equal to what? I times T. Q is equal to 0.15 ampere times 60 seconds is equal to 12 coulombs. So we need 12 coulombs or coulombs of a charge flow around the circuit to have what? 150 milliampere in 1 minute. In 1 minute. So current are given, times are given. We need to find what? Q. Q is equal to I times T. Okay, I think this is all for today. Thanks for listening, and we will see you next time inshallah. Thanks.